Implicit is when, for example, we have this equation here, y is equal to 2x to the power 3, then minus 3x plus 4. Yeah. So in this case here, it's very easy for you to differentiate y with respect to x. So you can just go direct and use the standard derivatives for this one here. You can just differentiate y with respect to x direct. So in this case, you have dy dx is equal to 6x squared minus 3. So this is what explicit. Explicit. Yeah. Explicit differentiation. Yeah. So in this case, y is already the subject of formula. You just go direct and differentiate. And this is what we call explicit differentiation. But as we are not... Yeah. So as we are not going to look at this type here, we are going to look at implicit differentiation, whereby you have an equation, but it is impossible for you to make y as the subject of the formula. That's what we're going to look at. So we have this equation here, y to the power 3 plus 2x square is equal to y to the power 2 minus x. Yeah. So when you see this here, we have y to the power 3 this side and the y to the y square this side. So this one here, for you to make a y as a subject of formula, it's very difficult for you to make y as a subject of formula. Therefore, you are required to use implicit differentiation, which will help you to differentiate such type of... Wherever you are differentiating y, so we have been given this equation here, y to the power 3 plus 2x squared is equal to y squared minus x. So for you to make y as a subject of formula here, it's very difficult for you to make y as a subject of formula. So what you're going to do is, you are going to use implicit differentiation. Then what you are going to do is, you are going to multiply the whole of this equation by what? By dy dx. So I said you should note that when you are differentiating y, for example, you have been told to differentiate maybe, let me say 2y to the power 4. So wherever you are differentiating y, always the differential of this will be this multiplied by this is 80, then y the power reduces by 1, so it will be 3, 8 y to the power 3. So since you are differentiating y, always you should multiply this by what? By dy dx. Always when you are differentiating y. Are you clear now? Hello? Yeah, no, I mean when you are differentiating y. When you are differentiating y, okay, you see what I mean here. You see. So let's multiply dy dx. Come again.
I'm just asking for what is why.
Yes.
So I was asking the end is supposed to have what x.
Yeah. So y should have a dy dx whenever you are differentiating y. You have seen the way I've done here. I've multiplied this by this is 8, then the power reduced by 1, so it will divide the power 3. Then you multiply by dy dx since we are differentiating y. So let's multiply this dy dx multiplied by this equation. So we have y to the power 3, then dy dx, then plus this multiplied by this is 2x squared, then dy dx, the equal to this by this you have y squared dy dx. This by this is x dy dx. Okay. So now we are going to differentiate term by term. So we have this first term here, y to the power 3 dy dx. So we are going to say, I'll drop the power 3, then y will reduce by what? By 1, so we have 2. So since we are differentiating y, I will include the what? The dy dx. Dy dx. You have seen here. You have seen what has happened here. Yeah. So now, then x. This x here, it won't have the dy dx. So you just multiply, drop the power, so it will be 2 multiplied by 2, which is 4. Then the power reduces by 1, so it will be just x to the power 1. Don't include the dy dx since we are differentiating the what? The x. So then equal to, again we have y. So it will be 2y. The power reduces by 1, so it will be y to the power 1. Since we are differentiating y, we include the what? Dy dx. Dy dx equal to, we are now differentiating x. So the differential of x is just 1. So now our aim here is to find dy dx. Our aim is to differentiate this equation. So it's dy dx. We want to find the value of dy dx, the expression for dy dx. So what we are going to do is we are going to do the right terms. So we have this one has dy dx and this one has dy dx. What we are going to do, we are going to say this, which is 3y square dy dx. Then we have this term here. So when it comes this side to be negative, 2y dy dx equal to, we have this negative 1 this side. Then we have this term here, positive 4x. It doesn't have dy dx, so to go this side, it is 4x. Then next, our aim is to find dy dx. What you are going to do here is that dy dx is common here. It is here and here. So we are going to factor out the dy dx. So I'm going to say dy dx open. Here I'll remain with what? I'll remain with 3y squared minus, here I'll remain with what? 2y equal to negative 1 minus 4x. Anyone who is lost?
No, we are following.
All right. Okay.
But now we can't see what is the bottom.
All right.
Just the
Yeah. Yeah. So we have this now. What are we going to do here for us to remain with dy dx? Since we want the variable or the expression for dy dx, what are we going to do in this case? Hello, is a question? Anyone to help us? What are we going to do in this case to have dy dx? What? Yeah. So in this case, for us to remain with dy dx, what we are going to do, this is the same as you have 2x equal to what? To 1. So they want us to find the value of x. Just divide by 2. Then you have your x equal to 1 over 2. So this is the same as this one. So what we are going to do, we are going to divide the whole this by 3y square minus 2y. Both sides. This will go and remain with dy dx. So this is equal to negative 1 minus 4x over 3y square minus 2y. You can end here. If you want, you don't want a negative this side, you can just multiply by negative on top and down. By negative, by negative. Then you are going to have, on top you are going to have positive 1 plus 4x. Down you are going to have 2y minus 3y squared dy dx. Then you are done. Any question? Yeah, so I'll assume there are no questions. Everyone is clear. Yeah, so let's look at the next example. Next example, we have sine y equal to what? X squared plus 2x then y. So we have this expression here. So in this case again, it's very difficult for you to make y as the subject of what? Of formula. Then what you're going to do is you're going to use the implicit differentiation. Then the method is the same. You are going to multiply this by dy over dx. So when you multiply this by this, you are going to get sine y dy dx equal to x squared plus this and this 2xy dy dx. This is what we have here. Now we are going to differentiate each term. This term here, so yeah, sorry. So there's we are supposed to multiply this again by dy dx. Yeah, plus 2x dy dx. So we have multiplied this by this. We are going to get this, this, and this. So we are going to differentiate now each term. So let's start with sine y. So sine y here, we have this sine y. For you to differentiate sine y, you are supposed to use what? A chain rule. So let's say sine y, we have here sine y. We can differentiate sine y separately. Yeah, so we can differentiate sine y separately. So the differential of sine y, what you are going to do, you are going to say sine, let's replace y by t. So this is going to be cos what? Cos t. Then what you are going to do is you are going to multiply by the differential of what? Of t. So t in this case, our t is equal to what? To y. Are you getting what I'm saying here? Yeah.
No.
You are not getting me.
So we are replacing with t.
Yeah. So listen first. We want to differentiate sine y. So what you are going to do is, you know the formula sine y. For you to differentiate sine y, you are supposed to use what? Chain rule, which is equal to what? Let me say dy, or let me equate this equal to what? To u. So it's going to be du with respect to y. Then you are going to have du over dt multiplied by dt over let me say the what? So we have this is u. Yeah. So let me say we have maybe or dx here. Yeah. So what I'm going to do is, so since this is the formula for chain rule, what you are going to do is you are going to say let u equal to what? Sine. Where there's y, I would place what? T. So when you differentiate u with respect to t, you are going to have what? So this is du over dt. We are differentiating u with respect to what? To t. So you are going to have the differential of sine t is what? Cos t. And then you have dt dx. So now you are going to differentiate your t. So since t is equal to what? To y. So you are going to say t is equal to y. So yeah, here we are supposed to have y. So we are differentiating t with respect to what? To y. So you're going to say dt with respect to what? dy equal to. How do you differentiate y here? Y, we are differentiating y now. So what you are going to do is the differential of y has the power 1 here. So you just say drop 1. You have dropped your 1. Then the power reduces by 1. So this is going to be just 1. So since we are differentiating y, you are going to include what? Dy dx. Then that's what you are going to put here. Dy over dx. Since 1 multiplied by dy dx is just dy dx. Then you have cos, where there's t now, we are going to replace it by what? By y. Then y, we have this dy dx. Question or questions. If you have a question, you can ask before we proceed. Any question? Okay. So there are no questions. So we are going to replace this here. So we have cos y dy dx equal to this one here, x squared dy dx. This is just 2x. So since we are differentiating x, we are not going to include the dy dx. Then plus, we have 2x y. So we can just pull out the 2 first. Then x y dy dx. So again, 2 terms are multiplying here, which means we are going to use what? Product rule. We have x and y. So what I'm going to do, I'll write x and y. And then product rule, the formula is dy dx is equal to what? U dv over dx plus v du over dx. So I'll say let my u equal to what? Equal to x. Then I'll differentiate u. So I'll have du with respect to x. This is just 1. Then I'll say let v equal to what? To y. So y. So dv over with respect to y, dy equal to. Now, what is the differential of y? Is what? This is just 1. So since we are differentiating y, we are going to have dy dx. Then you are going to replace in the formula. Our u is equal to what? X. Then dv dx. Dv dx. So in this case, we are supposed to put y here since we are differentiating y. So our dv dy here is supposed to have y. So it's dv dy. Dv dy is this term here. Dy over dx plus our v is y multiplied by du dx. Du dx is 1. So you have 1. So this multiplied by this, you have x dy dx plus this multiplied by this is y. Any question? So you're going to have cos y dy dx equal to 2x plus 2 open x y dy dx. We have this here. We have x dy over dx plus y. So we have cos y dy dx equal to 2x. So 2 multiplied by this, we're going to have 2x dy over dx. This by this, we're going to have 2y. Now, the same thing that we did last time. So we have dy dx this side. You have a question?
Why do we have y dx on the x, but yet we are trying to find the differentiation of y?
Yeah. So we have dy dx here with, since you have x here and here you have dy dx. This dy dx has come as a result of this formula here. U dv over dy plus v du over dx. So I said we are going to have u, our u is x. This is our x here. I'll put x here. Then what is our dv dy? So we said our u is what? X, which is this one. Our v is what? Is it y? Are we together?
Yes.
Okay. I want you to see where dy dx is coming from here, combined with the x. So u, our u is equal to what? X. So this is x. Then dv dy. Let's find dv dy. How do you differentiate y? This is y to the power 1. So y to the power 1, you drop the power which is 1, then the power reduces by 1. So it will be 0 to the power what? Y to the power 0, which is 1. 1 multiplied by 1 is 1. So since we are differentiating y here, we are going to put what? Dy dx. 1 multiplied by dy dx is just dy dx. So u is x, which is this one, dv dy. dv dy. dv dy is equal to what? Dy dx. This is what I've put here, dy dx. For the dv dy, which is this one, dy dx. I'll put it. Then we have plus v. Our v is what? Our v is y, which is this one. This is y. Then our du dx. We are going to differentiate u with respect to x, which will give us what? 1. So since we are differentiating x, we are going to have 1 on. So this is it. Yeah, so we have 1 here. So when you multiply x by dy dx, then you have x dy dx plus y multiplied by 1, which is y. So this is how we came up with x combined with dy dx. Are you clear now?
Yeah, thank you.
You're welcome. So next step, we are going to do the right term. So we have cos y dy dx. Then we have this one has dy dx again. So minus 2 dy dx. Then we have this side we have 2x plus 2y. Then again, we want to find the value of dy dx. We are going to factor out dy dx, which is common here. So I have dy over dx equal to, here I'll remain with cos y minus, here I'll remain with 2x equal to 2x plus 2y. So there is no equal to here. Yeah, so we have dy dx multiplying by cos y minus 2x equal to 2x plus y. Again, we're going to do the same thing. We're going to divide by cos y minus 2x, both sides cos y minus 2x. So this and this will go, are going to remain with dy dx equal to 2x plus 2y over cos y minus 2x. So this is the answer. Anyone with a question or who is behind? Hello?
So I have a question.
Yes.
When we're differentiating sin y,
Yes.
is it the same as derivative? Finding the derivatives of.
Yeah, it's the same. At what?
Thing you were mentioning something about what do you call it?
The chain rule.
Chain rule.
Yes.
Yes.
Yeah, because when you are differentiating sin y, the method which is used is chain rule. So, yeah, you know what, some people have mastered it. So, that's why they don't use a formula, but there is a formula which is chain rule. Yeah, so if you are good at mastering, you can just master it, then you go with it.
Okay.
Yeah. Yeah, so let's have the next question. The next question says, determine the values. The values Okay, so we have this question here. The question says, determine the values of dy dx when x is equal to 4, given that x squared plus y squared is equal to 25. Yeah, so they want us to find two values of dy dx at x is equal to what? To 4, given this expression here, which is x squared plus y squared equal to 25. So what you are going to do here, for you to find the value of dy dx, yeah, it's obvious. Yeah, the first step is to differentiate this one. So how are you going to differentiate this one to have a dy dx? So this is implicit, because we have x squared then plus y squared is equal to 25. Again, if you make the subject of formula here for y, it will be very difficult for you. Yeah, it will be simple, but for you to differentiate, it will be a problem. So, like in this case, we are going to use the same method, which is implicit differentiation. So again, I'm going to multiply by dy dx. So we're going to have x squared dy over dx plus y squared dy dx multiplied by 25 dy dx. Now we are going to differentiate term by term. So this will give us 2x plus this will give us 2y. So since we are differentiating y, we are going to have dy over dx. Again, this is equal to, so when you're differentiating a constant, it will give you a what? A 0. Yeah. So now let's make dy dx the subject of formula. We want to find the value of dy dx. So we are going to have 2y dy over dx equal to, when this comes this side, will be negative 2x. Then I'm going to divide by 2y over 2y. This and this will go. I'm going to have dy dx is equal to, again, this and this will go. I'm going to have negative x over y. So our dy dx is equal to negative x over y. But we have an expression here. They want us to find the value, which is a number. So what you are going to do is, where there's x, you are going to replace by what? By 4. But where there's y, what are we going to replace? So this is a question which goes to you. What are we going to do for us to find y? This y here. We have x, our x is 4. Here, our x is 4. What of where there is y? What are we going to put? Yeah, so anyone Who has an idea? Hello? My question is, the question says, determine the values of dy dx when x is equal to 4, given that x squared plus y squared is equal to 25. So we have dy dx. Our dy dx is equal to what? To this one. So this is an expression. This is not a value. This is an expression. But they want us to find the values of what dy dx. So simply means they want us to find a number. So for us to find a number, we have x. Our x is equal to what? 4. So where there is x, we are going to replace what? 4. But we have y down here. What are we going to replace where there is y? That's my question. What are we going to replace here where there is y?
I think you use the formula.
Which formula?
Value of y.
Yeah. What are we going to use?
X squared plus
X squared plus y squared. Then what are we going to do with it?
4.
Come again?
What's x to put 4?
Okay, so where there is x, we put what? 4. In the original.
Where is x, you put 4.
Yes. Yeah, so you are right. So where there's x, we'll put what? 4 on the original equation here. So original equation is this one. So where there's 4, I'll put this. Then you have this 25. So 4 to the 2, we have 16 plus y squared is equal to 25. So we want to find the value of y. We have y squared equal to 25. This will be minus 16. Y squared is what? 9. Yeah, so y squared is equal to 9. Then you just square root. So positive.
I can't see clear.
Are you able to see now?
Not that clear.
What about now? Are you able to see now?
Yes, but not that clear.
Ooh.
It's clear, sir.
Okay. Yeah. So we are replacing where there's x, we are replacing by 4. So we have 4 square, which is 16. 16. Then plus y square equal to 25. So we want to find the value of y. We say y square equal to 25 minus 16. So y square equal to what? This is 9. Then square root both sides, positive or negative. So we have y equal to positive minus 3. So we have y equal to 3 and y equal to negative 3. So we have two values of y. So now we want to find the values of dy dx. So first we are going to find the value of dy dx. Well, so we have negative x over y. So we have, where there's x, I'll replace by 4. Then again at y is equal to what? To 3. So this will be equal to negative 4 over 3. So this is the value of dy dx. At x is equal to negative x is equal to 4 and y is equal to 3. Then again dy dx is equal to, while there is x again, I'll replace by 4. Again, we have at y is equal to negative 3. So I'll place negative 3 here. Then we have 4 over 3. So we have dy dx equal to negative 4 over 3. Then dy dx equal to 4 over 3. Yeah. So these are the two values of what? Of dy dx. Anyone who is not clear, I repeat.
I think we're all here.
Okay. So let's look at the next example. Okay. So we have this question here. X squared plus 2x.
Try to increase the volume.
Point. Yeah, so we have the question on the board. Okay. So we have this question on the board, which is x squared plus 2x sine 4y equal to 0. Yeah, so again, for you to make y as the subject of formula here, it's very difficult. And it is the angle here. So it's very difficult for you to make y as the subject of formula. Therefore, implicit differentiation is required. So again, we are going to multiply by dy over dx. Then we are going to have x squared dy over dx plus 2x sine 4y dy dx equal to this by this 0. Now we are going to differentiate term by term. So we are going to have here we have 2x. So since we are differentiating x, we are going to have 2x only. Now our job is here. Yeah. So what are we going to do here to differentiate this one here? This term here, a very big term. Yeah, anyone to help? What are we going to do?
Do we use the product rule?
Yes, it's the product rule, correct? Since you have two terms, we have 2x and this sine 4y. So these are two terms multiplying. Then you are going to choose what? Our product rule. So we have 2x, then sine 4y. So we have this term here, 2x, and this term. Two terms multiplying. If you want, you can factor out the 2 since the 2 is for this one and this one. So we are going to have x multiplying by sine 4 then y. So we have done this. Yeah. So now let's differentiate x sine 4y. So again, you are going to write your formula dy over dx equal to, so this is product rule. What you are going to do is you are going to have u dv over dx plus v du over dx. Then let your u equal to what? The first term, which is x. Then du over dx equal to what? This is what? 1. So since we are differentiating x, we are not going to include the what? The dy dx. Then our v equal to what? Sine 4y. Again, this again chain rule applies. So what you're going to do is you're going to replace this sine 4y. You're going to replace 4y by what? By t. So your t is equal to what? 4y. So here now there is t, and the differential of dv over, yeah, so this is equal to what? When you differentiate this one, you're going to have cos t. Then you are supposed to multiply this by the differential of what? Or this one of t. So when you differentiate t is equal to 4y, you are going to have, this is just 4. So since we are differentiating y, you are going to include the what? The dy dx. So you are going to have 4 cos t dy dx. But we know that because our t is what? Our t is 4y. Then dy dx. Is it clear there? Are you able to see?
No, sir.
You are not able to see?
I'm able to see, but I'm not clear on what you just explained.
Okay.
Can you repeat on the last part?
Okay. Okay, bosses. Yeah. So I was saying, yeah, we have this here, u equal to x, then we have differentiated u with respect to what? To x. Now let's differentiate the second part, which is our v. So our v is equal to sine 4y. So we have sine 4y. For you to differentiate this one, you're going to use what? What we call chain rule. So chain rule, for you to differentiate chain rule here, you're going to say this is dv with respect to what? Dy. Then what you're going to do is you're going to say, you're going to let your t equal to this angle here. Your t equal to 4y. V simply means that v now is sine what? Sine t. Are we together? So again, differentiate this here, 4y. So we are going to say dt with respect to what? To y. So when you differentiate 4y, you are going to have what? 4. So since we are differentiating y, you are going to have dy dx. And then again, differentiate v sine t. When you differentiate v sine t, you are going to have what? Cos t. Then multiply this by the differentiation of what is inside here. The differentiation of t, which is t is equal to 4y. So we have this one here, which is 4 dy over dx. Still not clear?
It's clear now.
All right, process. Yeah, so we are going to multiply cos t by 4 dy dx. So we have cos our t is equal to what? 4y. So we're going to replace where there is t by 4y. We have, since you are multiplying, so we are going to have 4 this side, then the y, the x this side. So we have this here now. Now, what you are going to do is you are going to replace where there is so we have this formula here, u dv dx plus v du dx. Now I'll replace where there is u, I'll replace by what? This. So we are going to have u is what? X multiplied by dv dx. So here, since you are differentiating y, here you are going to put what? Y. So we are going to have dv over dy. dv dy is this one here. 4 cos 4y dy dx. Then we have plus our v. Our v is what? Sin 4y. So we have sin 4y. Then this is multiplying by what? By du dx. Our du dx is 1 multiplied by 1. So when you multiply this by this, I'm going to have x, we are going to have 4x, then cos 4y dy dx plus sine 4y. So this is our what? Our dy dx is equal to this one here. So we are going to replace this here, where there is x sine 4y dy dx. Now let's replace. So outside you have 2. So I'm going to say 2 open. We have this 4 cos 4x cos 4y dy dx. Then plus sine 4y equal to what? 0. Now we have 2x plus this multiplied by the whole this, you are going to have 8x cos 4y dy dx, then plus 2 multiplied by sine 4y, you are going to have 2 sine 4y equal to 0. Then again, make y to be dy dx to be your subject of formula. So we are going to remain with 8x cos 4y dy dx to the left side, then equal to this will move to this side and this will move to this side, since it doesn't have dy dx and this one doesn't have dy dx. So you're going to have negative 2x minus 2y, minus 2 sine 4y. This is the angle. Then now we are going to divide by 8x cos 4y, both sides. 8x cos 4y. So again, this and this will go and remain with the dy over the x equal to negative 2x minus 2 sine 4y over yeah. So you're going to have 8x plus 4y. So again, if you want, you can leave your answer here. So if you don't want the negative, just multiply on top by a negative. So in this case, you can just say dy x equal to, this will be positive 2x when you multiply by negative 1, and this will be plus sine 4y over negative 8. Yeah, so you're going to have x plus 4y. Yeah, this is markers. Yeah, so that's the answer. Anyone with a problem or you have a question? Any question? Okay, yeah, so this is the end of our lecture. Yeah. So if you have a question on implicit differentiation, you can just send in the group or inbox me. Then